Now let me have you guys' attention real quick for just a very brief going through of some of the tips. All right, first off, as you can see from the bottom left of that reference sheet, they say something about analyzing identities, the one you're trying to verify. Look for opportunities to apply, the fundamental identities. Okay. So let me show you something that we did yesterday, and you tell me if that seems like looking for opportunities to apply for identities. Now that's one of the examples we did yesterday, right? Checkpoint 3. And by the way, that's the same problem on page 222. Let's see, is that? Yeah. The same problem on page 222 from the packet. On the left-hand side, you see that 1C, right? They worked out that problem exactly. And, later you can try, the right-hand side of 1C, for a different problem. But here, so we decided to factor out that DCF sine x, right? And we arrived at sine of x factored out 1 minus cosine square on the left-hand side. But if you've never tried this, you'll see that, well, this identity came out of nowhere, right? What makes me believe that I'm going to use this one? But the thing is, remember that our goal is to show by rewriting, let's say, the left-hand side in such a way, then this guy, you will look exactly the same as the right-hand side, which is sine to the third. And that makes us think we don't like the cosine, right? And now let me put it this way at this moment. For probably the whole semester, as you're playing with the trig functions, whenever you see the sine square, I want you to think about cosine square at the same time. Okay, when you see cosine square, you should recall the sine square. Not to mention that you see that magical factor of 1. Can anyone tell me that what is the identity that relates the sine square and cosine square? And it's called, Christopher? Right, and that's the one over here, right? So now, I mean, yes, it's not that straightforward, but I want you to find yourself a good reason that when you see a 1 cosine square, 1 sine square, or even sometimes just sine square or cosine square, think about this guy, right? But what does it mean when they say look for opportunities to apply those identities? I mean, I don't think that this combination is ready for you to apply this identity. That means you have to do something, either massage this one, right? Or do whatever you can to the identity to try to fit it in, right? And that's why, maybe a different student will think to write this guy in a different way, or we figure that we're going to rewrite this identity in such a way, right? But at the end of the day, you want to put this in, right, and make it work. And now, of course, our goal is to get rid of the cosine, right? And therefore, I have to do some algebra. Using this identity, we're able to change the things in a bracket, right, in terms of sine, and later on, it actually works out. And again, this is not very routine, right? Sometimes you don't find any good reasons why I'm doing it, right, or doing certain things. And that's why, as you're practicing with those problems, or even the quiz problems, or homework problems, ask yourself that, why am I going from line 1 to line 2, right? Why am I using this identity? What was your thinking behind it? Because you need to find yourself, not necessarily a good reason, but force yourself to think about a good reason to convince yourself why you're using the identity in such a way. And as you're doing that for over and over again, and you will see that later on, this is going to be, kind of natural, right? And just so you know, it's exactly just like when your coach tells you to do certain things for 100 times, like they make it a drill, not just making like one move, right? I like to use tennis, since I always watch the coach yelling at my son, but in a nice way, right? So they say, hey, do a split step, right? Go to the center, right? Do a swing, get back, right? Split step, go to the center, swing, go back. Now, what upsets me is the coach has to say it every single time for my son to do it. I'm upset because, I'm telling my son that why don't you do it on your own, right? I'm not paying the coach to yell at you for 100 times, wasting time. You do it, right, after 3 times, right? But why do you think that they have to repeat, the same thing for, ever since that, he started to, practice the footing? It's to get used to the same way, right? And then later on, you find it natural and you stop asking why. Because right now, yes, Dr. Ron, why are you doing this? I don't see why. I wish I have a good reason to tell you, right? But you need to get used to, certain tips, right? Anyway, now, the thing I think I can share with you, let's get back to the tips. Now, let's take a look at number 3 and 4. Number 3 says that if you see a single term of quotient, like a fraction, separate it, right? Or split up to get 2 terms, right? I used to just call it splitting the fraction or splitting the numerator, right? But then you say, wait a second. Number 4 says combine fractional expressions. That means if you're looking at those guys, they want you to combine them. But why 3 and 4 are asking you to do 2 things that are exactly opposite to each other? You might say, well, then which one do I do, right? Then I have to say that it depends. And this is why you need this kind of a tips, right? Or some general strategy. And I'll say that it won't hurt if you try this or that just to see. But later on, you'll realize that in certain scenarios that you're better off to try number 3 and number 4. And again, you don't even have to ask why. It's just like, let's say if you know how to cook, basically, and compared to your mom, right? So if you both cook the same dish, right, and she cooks a lot better, you ask her, hey, how do you know that you're gonna do this amount of portion of sugar, or why you do this? I didn't do that. She might not have a good reason for it because she said, well, I just know how that works, right? And you need to get to that stage, so you know it works, right? You know why 3 works out, not 4, right, or the other way around. Now, did we do that? Well, let me show you that we did that yesterday in the super lengthy example, right? So now if you're trying to recall what we did to get started, so you're looking at a very complicated identity, right? You know that your goal is to make the left-hand side look just the right-hand side. Why we picked to start from the left-hand side? We probably didn't say it. Or you might think that because you read from left to right, that's why you always start from the left-hand side. Well, that's one reason sometimes, because it turns out that it works out either way. But do you see that you're trying to compare the left and right-hand side, and you're going to have to do something because they don't look the same. To pick the side, so now would you pick a more complicated side and to do a lot of trims and simplifications to make it look like the easier side? Or would you rather just start from the easier side and make a big deal and make it super complicated and then eventually look like the complicated side? And I think that usually you start from the complicated side to make it easier, might work out better. Right? And this is actually also one of the tips. So if you can take a look at, well, you know what? I'll show you on the screen. They did mention they start with the more complicated side. Well, I didn't tell you why, but I hope that maybe just with some common sense, you think that this is probably like a good strategy. Anyway, so we started from the complicated side, which is on the left-hand side, and we realized there are 2 fractions, right? So now 3 says split the fraction. Number 4 says combine the fractions. In this case, I hope you realize you better combine the fractions. Okay. But to do that, well, they didn't say how to do it, right? So you're gonna have to use the common denominator. The good news is you are almost always gonna get only 2 fractions to combine. That means you only deal with 2 denominators. Okay. And your best bet will be multiplying the 2 denominators to get you the common denominator. Right? Don't even think about it. go with the common denominator by multiplying the two guys, right? But why am I multiplying sine of x, right, with the first denominator, but 1 plus cosine of x with the second denominator, right? That's a question you're going to ask yourself, right? And once you get to the same denominator, you know that this is really how things get tedious. Because later on, you see that you're going to have to add up the numerator, right? And when you get to this part, if you were wondering why I decided to FOIL it, again, you know, I wish I have a good reason. But deep down, maybe I've been doing it for so long, I just knew it worked, right? And you need to also know that it's going to work out. Okay. Now, but what I just said, if you see the sine square, I want you to think about cosine square, right? Vice versa. So maybe if you want to really find yourself a reason why you have to FOIL it, like I said, seeing sine square, you hope that you want to get the cosine square. How are you going to get it? The only way to get it is to FOIL, right? Anyway, and also later on, you are alerted, right, to those combination of sine square, cosine square. Again, that's, you know, that one of the most important identities, right? Anyway, so I think that should be, you know, good enough to help you recall those skills, you know, which are not really that intuitive, but somehow I think that they will work out pretty nicely, you know, as long as you are getting more and more comfortable doing them. Now, let me, because I don't want to rush since, you know, we don't have the full class yet. So I'll wrap up the, you know, topic tomorrow, and that's why you better bring the packet. So then we'll make sure that you're comfortable with all the problems. But right now, how about I give you maybe like 15 minutes to give it a try. To those problems on page 2, let me see, 223 and 224. All right, so it's 1D and 1E. Okay. So again, please take advantage of the guided example on the left and work out the problem, you know, the same exact way, but, you know, see the variation, right? Okay, so 1D and 1E, do the best you can. Do not skip any steps right now. Later, I suggest you do that in a test, you know, just to save some time. But right now, feel every step, all right, and you know, get yourself, you know, familiarized with the logic. All right, go ahead. All right, page 223, 24, 1D and 1E. Yes. 1D, 1E. Yeah, those are the two tedious ones. Try to make it to 1E at least. Work on it, or if you can finish 1E, that would be great. If not, not a big deal. But please, know that that will be the level of some test questions, even the harder questions on the test or quiz. So that's the level you want to be. Okay. Nothing hard. Algebraically, it's I would say labor intensive. All right. So there are so many steps. Anyway, 5 more minutes, then we'll move on. All right, guys, let me get your attention for one more example, and we'll work out together. But please make sure that don't lose the packet. Bring it tomorrow. We will wrap up everything, and I want you to spend more time with those problems. Uh, and so I'm sure that, but I hope that by the end of tomorrow, you guys will feel more confident working with those quiz problems, right? And seriously start, getting the first, I'll say 6, 7, or even 8 problems done as soon as you can, then you'll see that we will probably do 6.2, 6.3, a bit quicker than we normally do for 2 topics. So you should be expecting getting ready by mid next week or maybe at the end of next week to come and get your quiz done. All right. Anyway, let's take a look at, let's see here. Checkpoint number 8. And again, if you be reading the e-textbook, that's I think that one of the exercise towards the end of the section 6.1. And you can probably tell, this is probably the problem that combines pretty much everything so far, right? Because you do see that both sides are kind of complicated. You have denominators, and also you have some functions that are not sine and cosine. And they literally mention you might want to work with both sides, right, separately to verify the identity. But the thing is, you're not able to really work on 2 different things at the same time, right? I know that they have something called multitasking, but I mean, things are not really that much different. Or let me put it this way. Can anyone draw a circle with a left hand and a square with a right hand at the same time? Now, if you actually try it, it's not impossible, right? And maybe some people are just very talented, right? Because the left of brain and the right of brain are very balanced out. But that's not what they mean by doing both sides, right? So you still pick a side, and I'll say that pick the more complicated side, right? So we'll just say that the left-hand side, not because we read from left to right, but in this case, again, the left-hand side seems more complicated, right? And we see 2 fractions according to one of the tips, right? I think that's tip number 4, combine fractional expressions. Again, the good news is there are 2 denominators which looks very different from each other, right? Well, they both share the sine function, right? But one plus sign, one minus sign are very different. So let's figure it out how to rewrite both fractions in such a way that they're going to have the same denominator. Starting from the first one, right, so I'll write it as 1 over 1 plus sine theta. But the common denominator will be the product of the 2 denominators, right? So that's why I will multiply both the top and the bottom of the first fraction with the other denominator. Okay. Then we move on to the next fraction, and we'll do the same thing. This time multiplying, again, whatever denominator you're missing, right, in the common denominator, which better be the first guy. 1 plus sine theta. Let me also color them. You can see exactly, the reasoning behind we swapping denominators and multiplying them. So I multiply the first fraction, both the top and bottom, with the factor 1 minus sine squared. Oh, sorry, 1 minus sine. That's because this is the second denominator we saw over there, right? And we multiply the second denominator with the first one. Of course, you have to make sure that you multiply the same thing, right, to both the top and bottom of the second fraction. Okay, so again, and indeed, it looks like a swapping things around and multiply both the top and the bottom, right? So now the next step is obviously combining the numerators Now, in this case, we don't have to FOIL anything yet, right? Because, 1 multiplying anything is trivial. So you're going to go with 1 minus sine theta, right, plus 1 plus sine theta over 1 plus sine theta times 1 minus sine theta, which is, as you can tell, the common denominator. And of course, you want to simplify the numerator. The negative sign and sign cancels out, right? So you're left with 2 over 1 plus sine theta, 1 minus sine theta. Okay. But let me pause for you to think about what should be the next step. And honestly, I think that this is probably a very realistic situation in a test, that you think that you're in the right direction, you are, right? You get to something which seems a lot nicer than the original expression, right? But what if you get lost, right? So like, what are you gonna do? So if that happens in a test or quiz, ask yourself that what you want to go at the end, right? Your goal is the right-hand side, right? So now here, I mean, this is getting better, but this is nowhere near the right-hand side, right? But you notice that the right-hand side, well, was a bit easier, but it has something that's not something that we like to deal with, right? It has tangent. What we like to deal with are the sines cosine. That means you're going to turn the right-hand side into, for example, the tangent using the quotient identity, right? Tangent is the sine over cosine. But you're going to square the tangent. That means you're going to square the sine on the top and also the cosine on the bottom. But you might say, wait a second. I have sine square and cosine square going on, right? Or I have a denominator on the right-hand side, which later on is going to become cosine square. What's the denominator here? Do you see that? Like I said, if you see a cosine square or sine square, think about the other guy. If you're looking at cosine square on the right-hand side in the denominator, should you get sine square on the left-hand side as well? Or do you notice that there's a factorable one, right? A magical factor that relates the sine square and cosine square. And now, hopefully, you realize, oh, you know what? Let me just expand it, right? By multiplying or FOILing the denominator, not to mention, you realize that's actually even better than a general FOILing, right? You guys notice that it's taking a pattern of the sum of two things times the difference of two things. When they expand, you get what we call the difference of squares, right? And that, again, gets you another reason why you should think about doing it, because it's simple, right? But sometimes you see that we factor, right, the different squares. But this time, you expand it, and again, you need to find yourself a reason, in this case, why we're expanding, not factoring. Anyway, so you might not be able to, agree with me on the logic behind expanding the denominator, but wait for the denominator works out, and hopefully you will start to get used to that kind of logic. Now, by expanding or multiplying these guys, is it okay if I just put 1 square minus sine square without FOILing? Don't you see that actually the two terms cancel out? That's the expansion formula for difference of squares, right? And of course, it goes like, or you know what, just to save some space, I'll put it on the side. 2 over 1 minus sine squared theta. So let's say if you don't know what else you should do, then you want to be like a little bit more conservative. Let's leave it as is, and let's take a look at the right-hand side. So the right-hand side is 2 plus 2 times tangent square theta, right? And like I said, we're going to turn it into something to do with the sine or cosine. So it'll be 2 plus 2 times sine over cosine. Since you're squaring the tangent, that means you're going to square the top and the bottom, right? Oops. Wait, where's the eraser? Okay. Right, are you guys okay for me writing instead of tangent square, cosine square over cosine square? Right, that's due to the quotient identity. Now, if you're wondering what that 2 is going to do, that 2 is on the side, but it's equivalent to put the 2 on the top with the sine square, right? It's just 2 times sine square. But again, let me pause for you guys to tell me what you plan to do after this. What do you think? And this is actually what you stop, right, for the left-hand side. I mean, this is getting somewhat close because at least there you have sine square, cosine square. But how would you turn, let's say if you're working on the right-hand side right now, how would you gradually turn it into something closer to this guy? Right, and let me read to you one of the tips. Again, combine fraction expressions. Right, but there's only one fraction here. But this is actually why you want to do it, because the first term, if it was a fraction, it will be more complicated, right? This is an integer, but you can easily write it as a fraction, which is 2 over 1, right? So now let's combine them by finding the common denominator, right? And I can tell already what it is, right? It's just cosine square. So I'll write the first fraction as 2 over 1. I'll multiply both the top and bottom with cosine square theta. Okay, add it to 2 times sine squared theta, cosine squared theta, right? And you're ready to combine them by putting the sum of the two numerators, 2 cosine squared theta plus 2, oh, sorry, there's a square, right? 2 sine squared theta, right? Over cosine squared theta. What next? Is there anything we could do to the numerator? 2 cosine square plus 2 sine square. Say it again, Anaya. Equals 1 if you take the 2 out, right? You're only getting, so yeah, so factor out the 2, so you see it better, right? Cosine square plus sine square, right? Over cosine square theta. And again, like Anaya said, according to the Pythagorean identity, cosine square plus sine square is going to be equal to 1. So you get 2 times 1, right? You don't have to put it anymore, over cosine square theta, right? So let me zoom out just enough so you can see what we have arrived at in on the left-hand side, right? And now what we have arrived at on the right-hand side, right? So do these two guys look the same? Or they don't look the same, but are they really the same? 2 over cosine square compared to 2 over 1 minus sine square. Again, you could do one more step if you want, right? Because like I said, whenever you see cosine square, think about the sine square, right? Not to mention you have that magical factor 1, right? And the sine square, you should go back and see, oh, sine square plus cosine equal to 1. Therefore, 1 minus sine square is indeed cosine square, right? So let me put it there. It is indeed 1 over cosine square theta. Okay? So that's not the last example, but I think that is the last thing I want to do today. Instead of pushing through everything, I do want to wait for the rest of the class to come back tomorrow, right? So yeah, just a few reminders. Please, bring this packet, and tomorrow I'll try to have you guys, work on the remaining problems. But feel free to, work on it if you want, later today. But like I said, please set aside some time to work on the quiz questions. Just a couple of problems each day. Also, please don't forget to get started with the homework 6.1. I think that you should be able to get to most of our problems at this point.